Now we are discussing about the composition of two collinear SHM having same frequency but different amplitude and phase. That means the two simple harmonic motions which are traveling along a same direction. Suppose they have the same frequency and different amplitude. So we are assuming x1 equal to a sin omega t and x2 equal to b sin omega t plus delta. Look, the two SHMs are represented by x1 equal to a sin omega t and x2 equal to b sin omega t plus delta. They have same frequency but different amplitude a and b. Let us suppose a is greater than b and delta is the phase difference between them. So they are in different phase, they have different amplitude but same frequency. Now what happens when they superpose with each other? Now from the principle of superposition we know that after superposition the resultant displacement will be x, that will be x1 plus x2. Now if we write x1 equal to a sin omega t and x2 is b sin omega t plus delta, and it is sin a plus b, that is sin a cos b plus cos a sin b. So it's equal to sin omega t cos delta plus b cos omega t sin delta. Now just taking common, we have a plus b cosine delta. If you take common sin omega t from the first two terms, and we left with b sin delta cosine omega t. Now to write it in standard form, if we write, suppose it is 1, to write it in standard form, assume that a plus b cos delta equal to some c cos phi and b sin delta as c sin phi, and putting all this value in the equation 1, we obtain that x equal to c sin omega t cos phi plus c cos omega t sin phi. So we have x equal to c sin omega t plus phi. Now look here, this is the resultant motion and the resultant amplitude is c, and it has a phase omega t plus phi, which is different than the constituting SHM. Now what is the value of c? If we just square and add these two terms, we have c equal to root over of a plus b cos delta whole square plus b square sin square delta. So if we just rearrange these two terms, we have root over of a square plus b square plus 2ab cos delta. And what is the value of phi? Dividing this equation by this one, we have tan phi equal to b sin delta divided by a plus b cosine delta. So look here, the resultant motion is also a simple harmonic motion, but it has different amplitude c, where c is root over of a square plus b square plus 2ab cos delta, and it has different phase, that is omega t plus phi. Phi is given by tan phi is equal to, just dividing this by this, it is b sin delta by a plus b cos delta. Now to obtain a particular value for a specific two cases we have shown here. For the first one, where the two incident or the two constituting simple harmonic motions, that is these two motions are in same phase, that is they have phase difference 0 when delta is 0. That means if delta is 0, then from this relation we have x equal to c sin omega t plus phi. When the value of c, the amplitude becomes, c is root over of a square plus b square plus 2ab cos delta. If delta is 0, the phase difference between the two superposing SHMs, if it is 0, then cos 0 is 1, cos 0 is 1, that gives c is a plus b, and from this relation we have tan phi b sin delta by a plus b cos delta. Sin 0 is 0, so tan phi is 0, which gives us phi is equal to 0, and the resultant motion becomes x equal to c is a plus b and sin omega t plus phi, that will be sin omega t. So they are in same phase. If the initial superposing SHMs were in same phase, then the resultant will be also SHM with the same phase but having different amplitude. The amplitude is nothing but the summation of the amplitudes of the constituting SHMs. Look here, it is a plus b. So now from this graph we can clearly see that if the x equal to a sin omega t is given by this blue line and b sin omega t, x2 equal to b sin omega t is given by this green line, and after superposition, look here, you get the red line a plus b sin omega t. So this is one case when the two superposing SHMs were in same phase. Now the second case where these two superposing SHMs are 180 degree out of phase, that is delta is pi. One is x equal to a sin omega t and x2 will be minus b sin omega t. Then from this relation we have cos pi is equal to minus 1, so we have c is equal to a minus b, and again from this relation sin pi is 0, so from here we get phi is equal to 0, so the resultant x becomes from this relation x equal to a minus b sin omega t. Just the resultant is also a SHM, but its amplitude is a minus b, that is the difference between the amplitudes of the constituting SHMs. Look here, if it is a sin omega t and the green line gives us minus b sin omega t, then this red line is the resultant, it gives us a minus b sin omega t. So these are the two special cases when two simple harmonic motions having different amplitude and different phase but same frequency moving in a same direction superposed with each other. In the previous section we have discussed about the composition of two simple harmonic motions of same frequency but different amplitude and phase traveling in same direction, that is suppose it is in x direction. Now we are going to discuss a different topic regarding the composition of two simple harmonic motions of same frequency but different amplitude and phase traveling mutually perpendicular to each other. Suppose one is traveling along the x-axis, then another is traveling along the y direction. They are mutually perpendicular to each other. So we can assume the two motions as x equal to a sine omega t, and another one which is perpendicular to this motion, it is y equal to b sine omega t plus delta. Look, they have same frequency, different amplitude and different phase. It is omega t and omega t plus delta, so they have delta phase difference between them. Now as they are traveling in mutual perpendicular direction, so the regular law of superposition is not applicable here. So we have to find out what will be the situation when they will superpose with each other. Now from these two equations we have x by a is sine omega t and y by b is equal to sine omega t plus delta. Suppose it is number 1 and it is number 2. And now from number 2 we have y by b equal to sine a plus b, that is sine a cos b plus cos a sine b. Now look here, we know that sine omega t is x by a, so cos omega t will be, from as we know sine square theta plus cos square theta is equal to 1, so we have sine square omega t plus cos square omega t, this is equal to 1. We know sine omega t is x by a, so from here we have cos omega t equal to plus minus root over of 1 minus x square by a square. And now by using the value of cos omega t and sine omega t and putting all this in equation, we have y by b equal to sine omega t is x by a cosine delta plus cos omega t is plus minus root over of 1 minus x square by a square into sine delta. Now if we take this term in the left hand side and square in both sides, so we then have y by b equal to x by a cos delta, this whole square, equal to 1 minus x square by a square sine square delta. We just have taken this term in the left hand side, y by b minus x by a cos delta, and in the right hand side we left with plus minus root over of 1 minus x square by a square sine delta. Now we are squaring in both sides, we have now these two terms. Now here we have y square by b square plus x square by a square cos square delta minus 2xy by ab cos delta, this is equal to sine square delta minus x square by a square sine square delta. Taking this term in the left hand side, we have, if we take x square minus by a square common, we have cos square delta plus sine square delta, that will be 1. So we finally have x square by a square plus y square by b square minus 2xy by ab cos delta, this is equal to sine square delta. So this is a generalized equation after superposition of the two simple harmonic motions. Look here, this is an equation of ellipse. It is an equation of ellipse and it is inclined to the 2D coordinate axes with 2a and 2b are the sides and it is an equation of ellipse, so it is drawn here. This represents the equation of ellipse inclined to the axis of the coordinates and contained within a rectangle of sides 2a and 2b. Look here, it is x square by a square plus y square by b square minus 2xy by ab cos delta equal to sin square delta. It is plotted here. Now we shall observe some special cases. First of all, if we take the delta equal to 0, that means the superposition of the two SHMs having zero phase difference, that is, if we call it case 1, if delta is equal to 0. So if delta is equal to 0, then what we have? We put it here, sin 0 is 0, cos delta is 1. What is delta equal to 0? Cos 0. So we have x square by a square plus y square by b square minus 2xy by ab. This is equal to 0. So this gives us x by a minus y by b whole square equal to 0. So we have from here y equal to d by a into x, that is y equal to mx. So this ellipse reduces to a straight line passing through the straight line having a positive slope, that is this one. This is the case for delta is equal to 0. So from here we can obtain, if it is theta, that will be b by a, y equal to mx. This is the first case. Now the second case. When delta is pi, that means the difference of phase between the superposing SHMs in 180 degree. That means they are 180 degree out of phase. Then from here we again have sin pi is 0 and cos pi is minus 1, that becomes plus 1. So we have x square by a square plus y square by b square plus 2xy by ab equal to 0, and from here we have x by a plus y by b whole square. This is equal to 0, which gives me y equal to minus b by a into x. Now look here, it is minus mx. It has a negative slope. It is also a straight line passing through the origin, just like one, but it has a negative slope. So this will be this kind of straight line. So from here y equal to minus b by a. The slope can be calculated from here. So this is the second case. So the last case what we are going to discuss is when delta is pi by 2. The phase difference of the constituent SHMs is 90 degree. So then we have from this equation sin pi by 2 is 1 and cos pi by 2 is 0. So we have x square by a square plus y square by b square. This is equal to cos pi by 2 is 0, sin pi by 2 is 1. This is equal to 1. Look here, it is an equation of ellipse. So we have, it was the case of delta equal to pi. Now this is the case delta equal to pi by 2. So we have ellipse. X square by a square plus y square by b square. This is equal to 1. We have an ellipse here. And now from in the same case, if the amplitude of the superposing SHMs becomes same, that means if delta is pi by 2 and along with it also again the second condition, which is a equal to b, that means the amplitude is same. So then this equation becomes x square plus y square. This is equal to, you can write a square or b square as both are same. It is an equation of circle. This is drawn here. Look here, a and b become same, so we get a circle. So these are all resultant of the motions when two super SHMs having same frequency but different amplitude and phase traveling mutually perpendicular to each other, superpose, we get this kind of. And these curves which formed, look here, all these curves which formed by the superposition of the two simple harmonic motions which were mutually perpendicular to each other are known as Lissajous figure, are known as Lissajous figure. And Lissajous figures can be produced by using a cathode ray oscilloscope, and by varying the ratio of the frequency of the superposing SHM. Suppose we may take omega 2 omega, omega 3 omega, then different kind of Lissajous figure can be formed. So this was all about the superposition of two SHMs having same frequency but different amplitude and phase traveling perpendicular to each other.